All right, ladies and gentlemen, today we're going to talk about lesson number 5, negative exponents. Again, remember, anything that you see typed, you need to handwrite in whatever your definitions, directions, and problems are. And then I'll let you know when I pick a color, what color that is associated with. So we're going to start getting into negative exponents. The table below, this guy, shows the approximate wing beat per minute for the following insects. Step number 1 asks me to write a ratio, in simplest form comparing the butterfly to the fly. I'm going to pick my math color to be blue. When I write a ratio, I just take the first word that I see, which is butterfly, and then I put the second word on the bottom, which is fly, and it's going to be a fraction, essentially. So I have 100 beats per minute for my butterfly, and I have 10,000 beats per minute with my fly. And it has asked for it in the simplest form, so I need to reduce. Something that's cool that I like about numbers that end in 0 is to simplify. I can just cancel a term out of each one. And it doesn't matter what order I do it in, as long as I cancel one of them. So that's the same thing as saying 1, because that's all that's left on the numerator, over 100. Next, I'm asked to write it using exponents. Well, how could I turn 100 into something with an exponent? Well, we've talked about 10 to the second. 10 to the second is 10 times 10. And I know that 10 times 10 is 100. So instead of saying 1 over 100, I could say 1 over 10 to the second power. You're going to want to, that didn't mean to do that. You're going to want to write this chart in your notes. What we're going to do is we're going to fill in any of the blank spots that you see. So all those blank spots. So again, I would pause the video if you need some more time to write so you can write these down. Then unpause so that you can get back in the idea. So exponential form. That looks like a base with an exponent. We're used to working with it. We just haven't identified that that's what it's called. Standard form is just a way to see the number. So 1,000. Because I know 10 to the third, the 3 means that I put 3 zeros after the 1. And 10 to the something is 100. Well, we just saw that one. That should be a 2. So that little box should be a 2. 10 to the first is simply 10, because I only have one 10. 10 to the 0, now this is the cool part. So let me back up a second. If I have 10 to the third equaling 1,000, because I take this 3 and it tells me how many zeros to write. Well, if my exponent is a 1, I'm just going to write a 1 and no zeros. Anything to the 0 power, one of our math properties, one of our math rules is that anything to the 0 power is always 1. Even if I decided to take 4,270 to the 0 power, I still get 1. So pretty neat. Now to do negative exponents, that's when I start getting into fractions slash my decimals, because remember, any fraction is just a decimal. So this one is 0.1. Which is just 1 over 10. And then this is 1 over 100, which is equal to 0.01. And then I have 1 over 1,000, which is equal to 0.001. All right, 6 to the negative third. So when we do exponents, when we deal with negative exponents, I need to type because I cannot handwrite on my board to save my life. This needs to be in red. First, we're going to write the problem as a fraction. Once we've done that, the negative exponents sink to the bottom. Which causes the negative sign to disappear. So I have 6 to the negative 1/3, so I turn it into a fraction. 6 and then 3 sink, it turns into positive. And you're asking yourself, well, what goes on top? Well, if I gave you the example of x over x to the third, I'd have x over x times x times x. And I'd have one group cancel out. And when they cancel out, what value did we say that they cancel to? Well, x divided by x is the same thing as 3 over 3. That equals 1. So now on top I have that 1 because I did my dividing. And even though I didn't start with a problem that looks like this, I didn't have another numerator to simplify, I always assume that it's canceled out at some other point. It's just hasn't been shown to me. So my answer is 1 over 6 to the third power. All right, let's talk about a to the negative fifth. We're going to again turn it into a fraction, drop the base, turn the exponent positive, and put a 1 over it. Taking a look at the next one, which you can't see, right? I again turn it into a fraction, drop the base and make the exponent positive, and put a 1 on top. Go ahead and try these 3. So there's your first 2, and there's your third one. Try those 3. So pause video, work those 3 out, see what we get, and see if we agree. Remember, I said anything to the 0 power is 1. All right, in order to do this next part, we need to discuss what's called a perfect square and a perfect cube. A perfect square is the same number times itself twice. So for example, 1 squared is 1 times 1, and 1 times 1 is just 1. 2 squared is 2 times 2, and 2 times 2 is 4. 3 squared is 3 times 3, which is 9, so on and so forth. And I understand that we know our multiplication skills, but I want to just have these written down so that it's something I can start being able to just list that information off. That's another thing that we're going to have to kind of keep in the back of our brains of information to know. Similarly, I have what's called a perfect cube. The difference between a perfect cube and a perfect square is a perfect cube is multiplied 3 times. So it's 1 times 1 times 1, which is 1. 2 to the third, or 2 cubed, is 2 times 2, which is 4, and then 4 times another 2, which is 8. Oh yeah. Same thing with 3 to the third, it's 3 times 3 times 3, which is 27. 4 to the third is 4 times 4 times 4, which is 64. 5 to the third is 5 times 5 times 5, which is 125. And 6 to the third is 6 times 6 times 6, which is 260. And just like with my perfect squares, I could keep going. But after 6, it starts to get crazy large and we won't use them. So I'd like you to get used to seeing these 6. Yes, 6, these 6 perfect cubes. Write the following using negative exponents without using -1. So this first one's kind of simple because I already have an exponent with my 5. It is a -2. So I keep the base the same. I bring the exponent back up and I tack a negative sign onto them. I've written the problem using the same base with negative exponents, and that negative exponent is not -1. Next example, 1 over 36. Now, 36 can't just come up. I need an exponent first, which is why if I go back a moment, we need to look on one of these lists. I'll give you a hint. It's on that one. Good. 6 squared is 36. So what I'm going to do is instead of writing 1 over 36, I'm going to write 1 over 6 to the second. Because we know 6 to the second, or 6 times 6 is 36. It's equivalent. All I've done is rewrite the problem in a different way. So with that same mentality of the one before, I keep the base the same, I bring the exponent up, and I make it negative. And I've rewritten that problem so that the exponent's negative and that the exponent value is not negative 1. Next one, again, I already have an exponent, so all I have to do is keep the base the same, bring up the exponent, and make it negative. I want you to try these ones. So I have 1 over 4, 1 over c to the 5th, and 1 over 27. I will give you a hint. The first one, you need to use your perfect squares. The last one, you need to use your perfect cubes. Go. All right, I hope we're able to get all 3 of those answers. All right, word problems. Bum, bum, bum. One human hair is about 0.001 in diameter. Write this decimal as a power of 10. So first, let's turn this into a fraction. Well, if I have 1, 2, 3 spots, that's 1 over 1,000. And why 1? Because it ends in a 1. But I know I could write that as 1 over 10 to the third so that it has a power of 10, meaning my base is 10 with some power. And then I want it not as a fraction or as a decimal. So I bring up the negative 3. And I write it that way. A water molecule is about 0.00000000001 meter long. Write that as a power of 10. Okay, so again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to move that one. It's a little crooked there. Which is the same thing as 1 over 10 to the 10th, which would be 10 to the negative 10th. All right, now we're going to put these together. There's a couple different ways to do all of these problems. One is not more technically right than the other. They're just different. Doesn't matter which way you start. All that matters is that you follow your steps correctly. So we have to make sure we're really solid on our different skills. Okay, we're going to be able to do this 2 different ways. I don't think I have. No, okay. I wanted to make sure I didn't have the next problem on the bottom of the page so that I didn't start to run into it. So I have the first way I'm going to do in red so that I can put them next to each other and you can see the difference between the 2 of them. So the first way is, let's talk about my bases. Well, I'm multiplying my bases. So since I'm multiplying the 5s, I take my exponents and I add them. So I have 3 plus negative 5. Well, when I have a battle here between the positive and the negative sign will always win. So this will turn into 3 minus 5, which turns into negative 2. And that -2 is not my answer. That -2 is my exponent. So I have 5 to the -2nd power. We discussed that negatives can turn positive by flipping them downward and making them sink. Now that he is sunk, I will actually go ahead and solve this. So 5 squared is 5 times 5, which is 25. So my answer is 1/25. So that's the first way. Now we already see what our answer is. So I could say, hey, why do we even need to talk about the second way? Well, because I don't want that to only be the one way that you think about stuff. I think about things in totally different ways than some other people, which is fine. But unless I vocalize the different ways that I think about them, how is anyone going to know that I'm thinking differently? So because of that, I want to show this again, and I'm going to show you how we get to the answer of 1/5. Instead of starting with approaching our exponents by adding and subtracting, technically subtracting because that was what we ended up having to do because of the negative, I am going to rewrite, I'm going to bring this again. I am on the struggle bus. I'm going to rewrite this part of the problem like we just did. So I have 5 to the 3rd times 1/5 to the 5th. And when he goes down, he becomes positive. And you're probably asking why I wrote that so large. Well, part of it is I'm going to pretend that there's an invisible 1 on the bottom because I know 5 to the 3rd divided by 1 is just 5 to the 3rd. I have not changed the problem. But now I've gotten it so I can multiply fractions. 5/1, yes, is still 5, but I still have a top now. Now I have a bottom as well. 5 to the 3rd times 1. I'm sleepy. Is 5 to the 3rd. I took the top times the top. Now I have to take the bottom times the bottom. So 1 times 5 to the 5th. Is 5 to the 5th. And it just looks like it's taking more space because I wrote this one a little bit bigger. That's all. And then again, I can subtract, and I see I have more 5s on the bottom. So I have 1/5 to the 2nd. And 5 to the 2nd is 25. So my answer is 1/25. And I don't know why my computer keeps randomly putting lines like that. Sad day. All right, next one. Again, 2 different ways to approach it. I didn't give myself enough space like I wanted to. Oh well. I want to show the flip way. So I'm going to show you one of the ways. I know I wanted to show you 2. I just don't have enough space. It's fine. So if I just gave you, pretend I just, gave you this problem. If I simply gave you that problem, you would start out by saying, okay, well, it's a negative, so he's going to turn it into a fraction, and he's going to flip to the bottom and sink, and the exponent goes with. But we talked about how even though it's a first power, we don't need to write that 1. Because if I have 1, I'm just going to see 1. I'm not going to identify that's just 1. So the W goes on the bottom. But that's not just the problem. I have W to the -4th on the bottom. So if I have negatives on top, they sink down to the bottom. But what happens if I have negatives already on the bottom? Well, the negatives on the bottom will float back up to the top. And when they float up to the top, they turn positive again. Just like when my negatives sink, they turn positive. If my negatives are already on the bottom, they float up to the top and they turn positive. So I have the top of 4 minus 1, which is 3. So I have w to the third power. All right, we've got 4 left. I want you to try this and evaluate it. So give me an answer, like don't give me things involving exponents. Multiply now. Bum, bum, bum. Where I have to multiply what? And now I'm evil. That's not the best. It's supposed to be 1 over 7 to the 29. 1 over 729. And my cat is trying to bite my toes. Look, I have it. Okay, so let's try this one. It's very similar to our last one. We're going to start by taking my exponent values and subtracting them. And I get a -2 and -6. So he goes down to the bottom. And then now that he's on the bottom, I take 11 times 11, which is 121. So my answer is 1 over 121. Yes. And then I have another problem, because we like extra problems, because we need extra help. So I see I'm multiplying here, so I take my exponents and I add them. So I have 9 plus -4, but I have a sign battle here. So the negative one's out, so I have 9 minus 4, and minus 4 is 5. But that 5 is not just my answer. That 5 is the exponent to the base of n. And since he's a letter or variable, I can't change him anymore. So it's just n to the 5th. Cat brought it back. Turns out we're going to play fish tonight. All right, you got this last one. I want you to try this last problem. So pause it, try it, see what you get. Hopefully you got b to the 3rd. And that's all we have, guys. I'll see you later.